Hello students, today we're going to look at section 3.3, which is rate of change in slope. This is going to be a quick review because I know you did a lot of this last year, so we're just going to make sure you have all of the important details necessary. Okay, rate of change is the rate at which something changes, how quickly or slowly something changes over time. Okay, so we're going to look at two tables first of all, and we're going to see if we can figure out what the rate of change is. Sometimes you probably learned it last year as constant rate of change, both are the same thing, and they relate to slope as well. So let's look at this first table. I have x and y, and I've got several ordered pairs in there. So I need to look for the change in the x's and the change in the y's. So in order to get from 1 to 4, I had to add 3. From 4 to 7, I added 3. From 7 to 10, I added 3. From 10 to 13, I added 3. Okay? Now let's look at our y's. From -6 to -8, I subtracted 2. From -8 to -10, I subtracted 2. From -10 to -12, I subtracted 2. And from -12 to -14, I subtracted 2. Not 12, 2. So in order to find rate of change, I need to do the change in y over the change in x. Okay? And you might remember that from last year as well when we used the slope formula. Change in y over change in x. So the change in y, everything is the same. So I have -2 over the change in the x is 3. It was constant. They're all the same. That actually makes this a linear function because the constant rate of the change is same. And this -2/3, because it can't be simplified, is also, you might remember, my slope. Okay? So this is also the slope. -2 over 3. Now let's look at the red example, and I'll use a different color marker. Let's see if we have a constant rate of change and what it is. So I'm going to look at my x's. From -3 to -1, I add 2. From -1 to +1, I add 2. From 1 to 3, I add 2. And from 3 to 5, I add 2. Okay? Now look at my y's. From 10 to 12, I add 2. From 12 to 16, I add 4. From 16 to 18, I add 2. And from 18 to 22, I add 4. There's a problem. The x's constant rate of change are all the same. The y values are different. That means there's no constant rate of change. So this is not a linear function. The constant rate of change has to be the same in order for it to be a linear function. So what I could do is to verify is I could say 2 over 2 does not equal 4 over 2. This change in y over this change in x does not equal this change in y over this change in x. So that makes it no constant rate of change, and it's not a linear function. Okay? Now, let's say for example that this number was a 4. That if I changed, you don't have to write this down, just see this. If that number is actually a +4 and that number is a +4, I would have a constant rate of change. But they're not, so we don't. Okay? So if we look back at the first example, I do have a constant rate of change. It's linear, and it happens to be the constant rate of change is the same thing as the slope. Okay? Constant rate of change can be the same thing as slope if it's in simplest form. Now let's look over here at this chart, or excuse me, this graph. Here's a graph. I have a line graphed on here, and I need to find the slope of the line. You'll remember from last year that we use what we call rise over run. My recommendation is always to start with a low point, okay, and go to a higher point, because then you're actually rising and not falling, since it's rise over run and not fall over run. Okay, so here we go. I've got 2 points identified. Isn't that fancy and handy? So I'm going to start at the lowest point. Here's the lowest point, and I go up 1, 2, 3 to get to the same level, and then I go across 1, 2, 3, 4, but I'm going to the left, so I have to use -4. Remember, left and down are negative, up and to the right are positive. Okay, so I'm going to do that again. I go up 1, 2, 3, which is my numerator, and then I go 1, 2, 3, 4 to the left, which is my denominator, rise over run, so my slope is negative 3/4. All right? Now let's say that I got a little crazy and I wanted to start at the top point, okay? So if I'm starting at the top point to get down to this lower point, I have to go down 3. And when I go down 3, that is a negative 3. And then I go to the right 4, which is positive 4. So my slope could be, I think you can see this, but I'll make sure, 3 over negative 4 or negative 3 over 4. Both of those are exactly the same. It does not matter which one of those is negative as long as they're not both negative. Because if they're both negative, then it's actually positive, because negative divided by negative is positive. But it doesn't matter which one is negative. I can choose either one. Or the real standard way to write it would be the negative on the outside and then 3/4, like that. All three of those are written correctly. So remember, from a table, we can find the constant rate of change to find our slope. And if there's not a constant rate of change, then it's not linear, so there's no way to find the slope because it's not linear. And then we have, from a graph, we can use rise over run to find our slope. Here's a quick recap. If you will, just draw these simple x and y axes and then the lines that are associated with them in pink. And let's just do a quick review. We've got the first one, example, we'll say number 1. Look at the slope of that line, and we know it's positive because it's rising from right to left. If we look at example number 2, the slope is descending from left to right, so that has a negative slope. In the third example, the slope is not changing. It's a horizontal line, and when the slope does not change, that is a slope of 0. Okay? And in the example number 4, we've got a vertical line. Go back to example number 3. I said that all wrong. None of the slopes change. They're all the same. I've got a horizontal line. Okay? And in my horizontal line, the slope is 0. So forget what I said in the first part of that. It's a horizontal line, the slope is 0. If you look at example number 4, in example number 4, we have a vertical line, and if we have a vertical line, then the slope is undefined. You are going to need to be able to identify those quickly to make sure you understand which lines are negative slope, which have a positive slope, which have a slope of 0, and which have a slope that is undefined. And the last thing for today's video is finding the slope of a line using the slope formula. Let's say we're not given a graph, we're just given 2 points. How can I find the slope? I could graph them and count, but there's another way. I could use the slope formula. And the slope formula is m equals y2 minus y1 over x2 minus x1. The 2's and the 1's are subscripts, so they're just identifiers. They don't mean anything else except identifiers being consistent. So let's say I'm given the points 3, 4 and 7, 0. And I need to find the slope of the line that's drawn between those 2 points. Okay? I get to pick which ones are the 1's and which ones are the 2's. I tend to like to pick the bigger numbers as the 2's because that means I can stay away from some negatives. So I'm going to call this x2, y2, and this x1, y1. Okay? You can do whatever you want to. It doesn't matter. These can be the 2's, this can be the 1, this, whatever. Just be consistent. Okay? So I'm going to say y2 minus y1. Here's the biggest thing. You get so involved in what you're doing, or you're talking at your table, or you're listening to your music and watching TV and texting and Snapchatting all at the same time while you're trying to do this, and you just think, oh, I'm going to put the x's on top. You just don't think, and you start with the x's because they're first and you put those on top. That's the biggest mistake that happens. Don't do that. The y's have to go on top, x's go on bottom. Make sure you pay attention to that. So I'm going to start with my y values. Excuse me. y2 is 0 minus y1, which is 4, over 7 minus 3. Okay, because x2 minus x1. And 0 minus 4 is negative 4. 7 minus 3 is 4. My slope is negative 4 over 4, which simplifies to -1. We are not going to change any of these slopes to decimals. If you get an improper fraction, leave it as an improper fraction in simplest form. If you get a proper fraction, leave it as a proper fraction in simplest form. If you can simplify it to an integer, then leave it as an integer in simplest form. Okay? Just remember, y's go on top, x's go on the bottom. Again, as I've told you before, you're great mathematicians, but don't trust yourself with negative numbers. Use a calculator. And the moment you've all been waiting for, here are your two practice problems for this video. The first one says to find the slope of the line that passes through 12, -3 and 8, 7. Remember to put it in simplest form if indeed you have a fraction. The second one is find the rate of change for this set of data. You're given a list of x's and a list of y values. Find the rate of change and make sure you put that in simplest form also. Take a picture, submit it through Edimodo, and you're done.